Yeah, on problems 1 through 4, solve and graph the inequalities. Alright, so for number 1, it's 3x minus 7 is less than negative 34. We need to solve for x and then graph it. So I will go ahead and separate the sides of the inequality. And I have x by itself over here on the left. So I'm going to solve for x by moving the negative 7 over here and dividing by 3. So let's add 7 to both sides. And we are going to be left with 3x is less than 27, negative 27. And we will divide by 3. And we get x is less than negative 9. So to graph this, I'm just going to slide over a little bit here. And if I'm looking at a number line, and I'm saying the values of x are less than negative 9, so I'm just going to pick, maybe this is 0, and I'll put negative 9 here. If the values of x are less than that, that means it's not equal to, so I use an open circle. And if they're less, I move to the left, so like negative 10, negative 11, and on. So that's why we show it going this direction. Okay. Number 2, 2x minus 5 is greater than or equal to 4. We need to distribute first. So 2 times x is 2x. And 2 times negative 5 is negative 10. We're saying that's greater than or equal to 4. Now we're going to solve for x. So add 10 to both sides. And we get 2x is greater than or equal to 14. Divide by 2. And we get x is greater than or equal to 7. Okay. And we are going to now graph that. So I'm going to draw a number line. And we'll use 0 and the number 7. And we're saying the values of x are greater than or equal to the 7. So they can be equal, so we fill in our circle, our dot. And then the values that are greater than 7 would be numbers like 8, 9, 10, and on. So we draw an arrow showing all numbers or all real numbers greater than 7. And number 3, we will solve for x. So subtract 8 from both sides, or add a negative 8. So negative 4x is less than or equal to 28. We will divide by negative 4. And this is important here. Whenever we divide by a negative number like this, we need to reverse the inequality symbol here. So it was negative 4x is less than. We're going to change that to now a greater than symbol. So that cancels. And I'm left with x is greater than or equal to, and then 28 divided by negative 4 is negative 7. Okay, so it's important when you divide by a negative number that you remember to reverse that symbol. So it was less, now it's greater. Okay, we're going to graph that over here. Okay, 0, negative 7 would be on this side, and it's values that are greater than or equal to. So we fill in the circle, and greater than would be this way. Okay, number 4, we will solve for x. As I can see, I've got x on both sides, so I need to move the x's either from here over here, or move the 5x to this side. I prefer everything to be on the left side. I prefer the variable to be on the left side, so I'm going to move the 5x over here by doing the opposite. So I will add negative 5x to both sides. Gives me negative 3x plus 9 is greater than negative 18, because those cancel. We will then move the numbers away from the x so we can isolate the x. So we add a negative 9 to both sides. Get negative 3x is greater than negative 27. and I will divide by a negative 3. And here we are dividing by a negative number again. So we need to reverse that symbol. So we get x is less than, and then negative 27 divided by negative 3 is a positive 9. Now I'm going to graph that. So say 0 is here, 9 would be on this side. And the values of x are less, so open circle, not equal to, right? And then the values are less than that, so we move to the left to get, or move to the left to get less. Okay, number 5, write the inequality for the given graph. Okay, for this, we have a starting and a stopping point, so we're starting here, and we're going to stop here. So any number I pick for x is between these two numbers. I see an open circle, so not equal to, closed circle, equal to. Alright, so our starting point is negative 3, and that's going to be less than anything we pick for x. So the value of x has to be greater than that. See, x is greater than the negative 3 if I read it backwards. Or negative 3 is the least amount, so that's less than any number I pick for x. And then we can keep going until we get to 5, and it tells us to stop. And it says it can be equal to 5. So this is saying x is all of the numbers, decimals, fractions, however you want to say it. It's all, or the whole numbers. It's everything between negative 3 and 5. It's not equal to negative 3, but it could be equal to 5. Number 6. Simplify the following expression. And simplify just means to make it a smaller problem or a simpler problem. We're not solving for anything. There's no equal sign. So I will make it a smaller or a simpler problem by distributing first and then combining like terms. 3 times 4 is 12. 3 times a negative 5x is negative 15x. And the negative 2, remember the sign in front goes with that number. So negative 2 times x is negative 2x. And negative 2 times 9 is negative 18. Okay, then I want to combine my like terms. So we're going to take our x's first. I have negative 15 of them and negative 2 of them. So if I combine them or add them together, I get negative 17x. And then I have 12 plus a negative 18. It's negative 6. So this is our simplified expression. Alright, given the equation 3x plus 4y equals negative 24, write the x-intercept and y-intercept as ordered pairs. Okay, so to get x and y-intercepts, we know anytime we see the word intercept, that one of the values in the ordered pair is going to be 0. So either the x is 0 or the y is going to be 0. So if I'm looking for the x-intercept, I'm looking for the value of x when the y is 0. I'm going to write 0 over here for the y value, and I'm going to solve for x. So if I substitute the 0 in right here for y, 4 times 0 is 0, so it's like that's not even there. Okay, so I'm going to rewrite the problem as 3x equals negative 24. Okay, and I am going to solve for x now by dividing by 3. And x is equal to negative 8. Okay, so I'm going to put negative 8 here. Okay, to find the y-intercept, we're going to say that the x is 0, and we need to find the value of y now. So 3 times that 0 is 0, so we're going to just act like that's not there at all, and write the problem for y equals negative 24. And we will solve for y by dividing by 4. So y is equal to negative 6. So that's how I would write them as an ordered pair. Okay, number 8. The graph of a line is represented by the equation y equals 1/3 x minus 2. If the equation is changed to y equals negative 2x minus 2, what is the relationship between the two lines? Okay, so we're just basically looking at what's the difference between the lines. How did it change from line 1 to line 2? All right, so the first one was y equals 1/3 x minus 2. And the second one was y equals negative 2x minus 2. All right, there's only 3 things that can happen to a line. They can reflect, they can rotate, or they can translate. So in order for it to reflect, it needs to change from a positive to a negative or from a negative to a positive. So when I look at the slope itself, it needs to change from a positive to a negative. So when I look at the slope, this was a positive 1/3, and it has become a negative 2. So it's changed from a positive slope to a negative slope. So it has reflected there. Then the second thing that can happen is the slope can change, so it can rotate. Okay, so can it rotate? And when it rotates, we say one of 2 things happened. It either became steeper or less steep. Okay, and to be able to tell the difference, we just look at the number in front of the x itself. We don't care if it's positive or negative, because that's the reflection part. Okay, so if it's just because this is a negative doesn't make it less steep. Okay, so we're actually going to just look at the coefficient itself. 1/3, that's a fraction, and then the number 2. Okay, 2 is a greater number than 1/3. So for it to go from a 1/3 slope to 2, that means that it's going to become steeper. Instead of going just up 1 unit and over 3, we're going to go up 2 and over 1. So the rate of change is a lot faster. We're going up 2 and over 1. So the steepness is increasing. Okay, so it's becoming steeper to go from 1 to 2. And then the last thing we can look at is the y-intercept. We want to see, did it translate or did it shift? And when we're talking about lines, the shifting is going to take place on the y-axis. So we have to look at the y-intercept, and we decide how much did it shift. So where was our beginning point? Where was our first point that we looked at when we graphed this line? And when we are graphing lines, we look at that y-intercept, and that's usually the first point that we use. So we are going to put, this one is at -2, and this one also starts at -2. So that is going to be sitting on the same point. So it did not translate up or down any number of units. They're exactly the same. So there was no translation there. So if I'm talking about the relationship, I would say that it reflected across the y-axis and that it became steeper or more steep. Number 9, the length of the 3 sides of a triangle are x plus 2, 2x minus 1, and 3x plus 4. If the perimeter is 77, what is the value of x? Okay, to solve this, I need to understand a few things. One, we're looking at perimeter, and perimeter means that we are adding the sides up. So we're going to add these 3 expressions up: x plus 2, 2x minus 1, and 3x plus 4. And then we're saying that that perimeter, in terms of x like that, is 77. So let's go ahead and add the 3 together. So 3x and 2x is 5x, plus 1 more is 6x. And 2 plus a -1 is 1. 1 plus 4 is 5. So plus 5. and it says it is 77, so that equals 77. Okay, solve for x. So minus 5, and we get 6x equals 72. I'll write that over here. 6x equals 72. And then we're going to divide by 6, and we get x equals 12. So it says, what is the value of x? The value of x is 12. It can be nothing else for that perimeter to be exactly 77. And number 10, what are the values of x so that the perimeter of the triangle is less than 63? Write your answers in inequality. Okay, similar problem. We're still going to add up the sides. And instead of making it equal to 63, we're going to say that the value of that perimeter has to be less than 63. So I'm going to make it a little bit bigger, and I'm going to slide it over. And we're going to add the three sides up. So I have 2x plus an x. That's 3 x's. And 4 and 11 is 15. And a negative 3 is going to be minus 12. And then right here in the problem it says that perimeter is less than 63. So this perimeter here is less than 63. Solve for x. And 3x is less than 75. Divide by 3. So the value of x has to be less than 25. Okay. So value of x could be anything less than 25. And I don't know how it's going to be on the test. It could be a compound inequality, because that's actually what it should be if we were to figure this out, because I couldn't have a side that's any less than 0, or it couldn't even be 0, so x could not equal negative 4, because that would make that side 0. And over here, x could not equal 3 halves, because if I put 3 halves here, that would equal 0. So technically, we should add 3 halves to the front side, like that. Now, I don't know whether it would look like that on the test. My guess is it would probably just be this part. But know that there is a lower limit too, because we cannot have a side length of 0 on a triangle. That just doesn't make sense. Okay. Number 11, given the function h of 4 equals negative 5, and h of negative 6 equals 7. What is the value of h of x when x equals negative 6? Okay, this is just a very simple, do you recognize the x and y values in function in a solution set for a function? So this is x, the value 4, and then negative 5 is the y. In this one, x is negative 6, y is 7. So they're saying, what is the value of h of x? So what's that function value when the x is negative 6? So all I'm doing is I'm just comparing it. I find the one that has negative 6, and it says, what's the value of it? Positive 7. So when it's negative 6, the value is 7. So we would just write h of negative 6 equals 7. And that's really what we're looking for right there, is the value of y. So what's the value of h of x? It's 7. All right, 12. On problems 12 through 17, write the inequality of the graph shown. Okay, I'm going to blow this up. And what we're looking at is an inequality here, a graph of one. And when I start to write my inequalities, the first thing that I look at is I look at the shaded area, and I determine that this is that the shaded area is above the line, so it is greater. So I'm going to write y is greater than. And then I look at the type of line that was drawn. Okay, we have a solid line, so that's equal. If it was a dotted line, it would not be equal. So I put equals. So the value of y is greater than or equal to. And now we need to find the slope and the y-intercept. So the slope, we're going to find two good points. Here's one, and here's another. So I see that it's going up 2 units and over 1. So m equals 2, or 2 over 1, same thing. And b equals, well, there's the y-intercept. So the b is located at 4. So I'd write this as y is greater than or equal to 2x's plus 4. Okay. Number 13, same thing. I'm going to look at the shaded region, and we see that it is located below the line. Okay, so it's everything under the line. So that means that the value of y is less than, and I see that it is a dotted line and not completely solid. It's kind of hard to see the dots. If I blow that up a little bit more, right, we can see that it's actually a dotted area. Okay, so it's not equal to, just less than, and we need our m and b. Okay, the b is located at -2, and the m, the next good point that I see, looks like about right there. So it's up 3 units and over 4. Okay, so we have 3/4 x minus 2. Remember, everything is going to have to be in slope-intercept form when we write these. Okay, number 14, same steps. Blow it up. We see the dotted line. All right. The shaded area is under the line. All right. So if this is my line, if I'm looking up or down, right, the shaded area is down, so it's below, so that's less than. So y is less than. We saw that it was a dotted line, so it's not equal to. And we need m and b. B is at 3. And the slope, we see that we have a negative sloped line, so we know that we need to write negative. And then the next good point, I think, is going to be about right here. All right, so how many units down did I move? So I just basically, I'm just going to move over a little bit so I can see how far down from here to here. Right. So it's down 1, 2, 3, 4, down 5. Okay, and then how far over? So to go from here to here is the same as going like that, right? We're making the same thing. So I had to move 2 units. So over 2. So y is less than -5/2 x plus 3. Okay, number 15. Okay, we have a dotted line again. And the values in the shaded region, or the shaded area, are greater than the line, so it's above the line. Okay, so we have y is greater than but not equal to, and we need the m and the b. The b is located at -2. And another good point, looks like it might be here. We see that we have a negative sloped line, right? It's going down. So I'm going to write negative here. And it's going down 1, 2, 3 units and over 1. So y is greater than negative 3x minus 2. Right, even though the slope was negative 3 over 1, when I simplify that, it's just negative 3, because I can always make that a fraction again by putting it over 1. And number 16, I'm going to increase the size. We see that we have a solid line here. Okay. All right, and this is one of those special case. It's a zero sloped line, and it only crosses the y-axis right here at negative 1. Okay. So if it only crosses the y-axis, and we also see that it is shaded under that line, we're going to say that y is less than or equal to negative 1. Okay, and then we're going to go over to number 17. And this is also another special case. We have a vertical line here. So it has an undefined slope, and we're looking at a dotted line here. So it's not going to be equal to. And since it's a vertical line, it's only going to cross one axis, and it crosses the x-axis. So instead of putting y is greater than or less than, we're going to use x. So x is greater than but not equal to, right? Because if I'm looking at that shaded region, if this is the value of x, which is 3, right? If I move over to the next x in the shaded area, that's 4, 5, 6, 7, and on and on. So the values of x are going to be greater than that 3. Okay, 18, circle the ordered pairs that are not a solution to 2x plus 3y is less than 16. So what we're looking for here is an ordered pair that does not keep this inequality true. So they're saying 2x plus 3y is less than 16. We want to find something that makes that false, right? So when I substitute these values in for x and y, we want to make that number, we want to make the side greater if we're looking for not a solution. All right, so I am going to rewrite, so it's 2x plus 3y is less than 16. I'm going to rewrite that here. So 2x plus 3y is less than 16. And I'm going to check each of these answers with them. So for A, we're going to substitute x and y in for the x and y in the inequality. Okay, so x is 5, so 2 times 5 gives us 10. So we have 10. And then 2 times this 3 gives us 6. So 10 plus 6. And we're saying that's going to be less than 16. Well, 10 plus 6 is 16. And now we're left with 16 is less than 16. And that is not a true statement. That's false. So I'm going to label that false. Letter E, we're going to substitute x and y. Okay. So same thing, we're going to take this 6 and put it in for x. So 2 times 6 is going to be 12. And then we're going to take that 1. So 3 times 1 is 3. So plus 3 is going to be less than 16. Well, 12 plus 3 is 15. And 15 is less than 16, so that is a true statement. We were looking for ones that were not true. So A would be circled, E would not. B, we're going to do the same thing. We're going to substitute in for x and y. X and y. That one's pretty easy. It's 3 for both the x and the y. So 2 times 3 is 6. 6 plus 3 times 3 is 9. We're saying that is that less than 16? 6 plus 9 is 15. And 15 is less than 16, so that is also true. So not an answer choice we're looking for. Letter F, Substitute x and y. Okay, x is 0, so 2 times 0 is 0, plus 3 times 6 is 18. We're saying that that is going to be less than 16. Well, 0 plus 18 is 18, and 18 is not less than 16. So this is a false statement. And we're looking for things that are not solutions, so we're looking for false statements. So F can also be circled. Alright, so here was the original problem. So I'm just going to use for C, D, G, and H. I'm just going to look at this. Alright, so X and Y. So 2 times X, or 2 times 7, is going to give us 14. Plus negative 2 times 3 is going to be negative 6. And we're saying that that is less than 16. And 14 plus a negative 6 is 8. And 8 is less than 16. So C is a true solution, or it's an ordered pair that works. Okay, G, we're going to substitute X and Y. So X is negative 4, so 2 times negative 4 is negative 8. And Y is 8, so 3 times 8 is 24. We're saying that that's less than 16. Negative 8 plus 24 is 16. And is 16 less than 16? And that's no, that's false. So they're equal to each other, not less than. So I'm going to write false. And we're looking for not a solution, or not true statements. So we'll circle that one. And for D, substitute in again for X and Y. So 2 times 8 is 16, plus 3 times 0 is 0. That's less than 16. Well, we get 16 is less than 16 again, which that's a false statement. So that solution is, or that ordered pair is not a solution. And then we would check H. So substitute in for X and Y. So 2 times this negative 1 is negative 2. And 3 times 6 is 18, so plus 18. And negative 2 plus 18 is 16. And 16 is not less than 16, so that is also false. And we will circle that as not being a solution. Okay. All right, number 19. Which coordinates are in the solution set for y is greater than 2 minus 5x? So I'm going to do the same thing. I'm just going to look and see, does this xy ordered pair, does that pair, when I substitute in x and y, does this stay true? Is it a solution? Okay, so let's go ahead and substitute in the xy's. So xy. So y is 3. So 3 is greater than 2 minus 5 times the value of x, which is 0 in this ordered pair. 3 greater than 2 minus 0. 2 minus 0 is 2. Is 3 greater than 2? And the answer to that is yes. So A is a good answer choice. And we're still going to check the other 3, because in the other review, remember we found an answer that actually the problem was written wrong. So let's just go ahead and go through them and make sure that they are or are not solutions. Okay, so we will label xy. I'm going to actually make this a little bit bigger. All right, so we'll label xy. And substitute the values in. So y is 7, and that's greater than 2 minus 5 times the x value, so negative 1. right here we have a negative 5 times negative 1, which is positive 5. So 7 is greater than 2 plus 5. 2 plus 5 is 7. And so now our statement says, is 7 greater than 7? And that is not a true statement. So we're not looking for B as our answer choice. Substitute x, y for this. Y is 0. Is it greater than 2 minus 5 times 1? Okay. Negative 5 times 1 is negative 5, so we're going to put 2 minus 5, and we end up with 0 is greater than negative 3. And that is a true statement. Okay, so we're going to circle that as an answer choice as well. And letter D, we're going to label x, y, and substitute the values in. So y is negative 3. And we're saying that that is going to be greater than 2 minus 5 times 1, or the value of x. Negative 3 is greater than 2 minus 5. And 2 minus 5 is negative 3. And negative 3 is not greater than negative 3. They're equal. So that is a false statement. Okay. Number 20. Which inequality has 3, 5 as a solution? So we're just going to substitute in the x, y values here again. So x, y. So in letter A, it's going to be 2 times x, so 2 times 3 minus 5 for y. And that's going to be greater than 1. So we get 6 minus 5 is greater than 1. 6 minus 5 is 1. 1 is not greater than 1. They're equal, so that is not the inequality that is the solution for. So we will check the next one. So 2x minus y is less than or equal to 1. We're going to substitute those values in, the 3 and the 5 as well. So 2 times 3 minus 5 is less than or equal to 1. 2 times 3 is 6. 6 minus 5 is 1. And 1 is not less than 1, but it is equal to 1. So this is a true statement. So B works. C, we're going to substitute those the 3, 5 in it as well. So 2 times 3 minus 5 is less than 1. And we end up with 6 minus 5 is less than 1. And 1 is not less than 1, so C is out. And it can't be D because I found a solution that worked. So, so B was our answer choice. 21. Given the inequality graph below, find the following. We need to find the slope, the y-intercept, what symbol we're going to use, and then are those 3 points solutions. Okay. So the slope of the line, I'm going to go ahead and figure that out by finding 2 points. I like this point here, and the next point that crosses at whole numbers would be here. So we're moving down 1, 2, 3, 4, 5 units. So it's down 5 and over 2. Okay, so I'm going to come over here where the slope is, and I'm going to write negative 5 halves. Okay, now we're going to go back and look for the y-intercept. That's located at 1, 2, 3. So depending on how I write it, it could be, we're just looking for the b, so we're going to write 3. If I wrote it as an ordered pair, it would be 0, 3, but we just want to know what the b is. The inequality symbol, well, if I'm on the line and I'm looking to see if the values are greater or less, we would see that we are shading below the line, so that is less. we see that it is a dotted line instead of a solid line here, so not equal to. So the inequality symbol that I would use is just going to be less than. And then we're going to check to see if these 3 points are solutions. So 1, 1. So I'm going to go over 1, up 1. And we can see that that is not in the shaded area. So this is not a solution. So that's a false point. 2, negative 3. I'm going to go over 2 and down 3. 1, 2, 3. That's going to be in the shaded area. So that will work. And 0, 2. So up 2, it's in the shaded area, so that is also true. Or that's a good point. So, is it a solution for 1, 1? No. 2, negative 3? Yes. 0, 2? Yes. Okay, 22. Given the inequality y is greater than or equal to 3x minus 7, answer the following. Will the line be solid or dashed? Well, in order to figure that out, we just see if it's equal or not equal to. We see that there is an equal sign, so it will be solid, so we will include the values. So solid. Will the shading be above or below? Well, we also look at the inequality here, so the values of y are greater. So in order to move greater, we have to move up, because we're talking about up and down movement, above or below the line. So greater is above, so right above. What is the slope of the line? Okay, so we're just going to look at the equation. So we have 3x. So the slope is the number in front of the x, or the coefficient. So the slope is 3 over 1, or just 3. They're the same thing. And what is the y-intercept? So we look at the number at the end, so negative 7. And that is our y-intercept, negative 7. Okay, 23 through 25, graph the inequalities. So we're just going to look at the m and the b. The b is negative 2. So I'm going to put my y-intercept at negative 2. And we're going to go up 4 and over 5. That's going to be here. And then up 4 more. Over 5. And then we're going to do the same going backwards. So down 4 and over 5. Down 4 more, and over 5. And we need to draw a line for those points. So is it a solid or is it a dotted line? And we see that it is not equal, so we do not make a solid line. We're going to leave it as a dashed or a dotted line. So I'm going to extend the dashes out just a little bit past my graph so that I can make sure that I know it's dashed or dotted. And then the values of y are greater than that line, so it's going to be everything above the line, so we will shade that area. Okay. Number 24. Y is less than or equal to 5x minus 3. We're going to start at negative 3, and 5x means going up 5 and over 1. So that's going to be here. Up 5 more, over 1. And I'd run out of space up, so we'll go down now. And it is equal to, so we will use a solid line to for the line. And the values of y are less than that line, so we are going to shade everything under the line or below the line. So if I'm standing on the line, below would be everything down. So we will shade that area in. Okay, 25. In order to graph this, we need to put it into slope-intercept form. So I'm going to move the x by adding the opposite to both sides. And I end up getting 2y is greater than or equal to negative x plus 6. Okay. We're going to divide both sides, or well, both, but everything by 2. So y is going to be greater than or equal to negative 1/2 x plus 3. If you're wondering where I got the 1/2 from, we have negative 1x here. So there is a number here even though we don't see it. So it's going to be 1 over 2 and it's negative. So negative 1/2. Then x plus 3. So this is the same thing as taking x and dividing it by 2. If I divide something by 2, I'm cutting it in half. So it's 1/2. Okay, now I know the slope and the intercept and the y-intercept. So I will put a point for the y-intercept at positive 3. And then the slope is negative 1/2, so down 1 over 2. I will repeat the pattern until I run out of space. And then I will do the opposite by going up 1 and backwards 2. Notice if I was to connect these dots, they would be in a straight line. It is a negative slope here, so we have a negative sloped line. So now we just have to decide what type of line am I going to use to connect the dots, and then which side am I going to shade above or below. So we see that it's equal, so we will use a solid line. So I'm going to draw a solid line through, extending out a little. And we're saying that the values of y are greater, so that means it's everything above. Okay. So I will shade that area. That's it. Okay. Number 26. On the graph below, show a function with a range of all real numbers less than 4. Okay, so first thing is I see the word range, and I know that that means we're talking about values for y. And for y, that's going to be our up or down movement. All right, for range, up or down. And we're talking about all real numbers less than 4. Okay. So on the test, it's going to be, they're going to use array, so they're not going to use a shaded area. They're just going to, draw a circle and then have an arrow pointing. So we're going to do the same on this. So if we can pick anywhere on, as long as y is 4, we can draw a open circle. So I'm just going to pick one. Oops. Let me blow that up a little bit. So let's pick maybe this point here and draw an open circle. And then the range is less than 4, so it could be an arrow going this way, or maybe I drew one from here going this way. It doesn't really matter because it's all real numbers that are less than 4 because we're moving in a downward direction. So we're talking about range, so it's down, and it's less than that value of 4 right here. So it doesn't matter where I pick the 4 to be as long as my arrow is pointing in a downward direction. Okay. 27. Should say Jacob is looking for a home in Key West that will cost no more than $250,000. He plans to put a $10,000 down payment down and has set his monthly mortgage payment at $925 per month. Write an inequality that could represent the time in months to pay off his home. Okay, so we know that Jacob had $10,000 as a down payment plus $925 per month, and he wants to buy a house that will cost no more than $250,000. All right, so the price of the house is the That's the greatest amount. He doesn't want to do any more than that, but he could get up to that 250,000 because it says no more than. Okay, so that means it could be equal to, but just no more than that. So we want to figure out how many months it would take him to pay off his home. So if we take away the 10,000 and then divide by 925, the number of months, we don't want to pay any more than that. So this side has to be less than the 250,000. All right, Rebecca is working 2 jobs to support her 2 children. To make ends meet, she must earn at least $1,200. During the day, she works at Oak Ridge High School, X, and the evening she works at Rico's, Y. Write an inequality to describe the possible earnings for X and Y at her 2 jobs. Okay, so she earns X at one job at the school. She earns Y at the other job. And to make ends meet, she must earn at least $1,200. So making ends meet means being able to pay your bills. So if this is what she earns over here, and this is kind of like her bills over here, we know that she has to earn more than or at least equal to $1,200 to make the ends meet. So her earnings must be more than or equal to $1,200.